Welcome back. Happy Tuesday. Today we are going to continue working on finding numbers, finding the patterns within those numbers like we started with yesterday. So let's look at this. I have a pattern, and my pattern is 18, 25, 32, 39, 46. So my first question is, are the numbers increasing or decreasing? The numbers in this pattern are increasing. That means they are going up. So now I need to find the rule. I need to find how to get from 18 to 25, from 25 to 32, from 32 to 39, and from 39 to 46. So if you remember yesterday, we said that if our numbers increase, we're either adding or multiplying. Well, knowing my multiplication facts, I know that there's nothing I can multiply by 18 to get 25. So I'm going to have to add, but I need to figure out what I add to 18 to get to 25 and see if that rule works for the rest of my numbers. So I'm going to take the number 18 and I'm going to put it in my head. And then I'm going to count up to 25 and see how many numbers in between there are. So I've got 18 in my head and I'm going to count up. 18, 19, 20, 21, 22, 23, 24, 25. There are 7 numbers in between 18 and 25. So let's try it again. Let's go from 25 to 32. So I'm going to put 25 in my head and count up. 25, 26, 27, 28, 29, 30, 31, 32. It worked. I added 7 to 25 and got 32. Let's do it again. 32 to 39. I'm going to put 32 in my head and count up. 32, 33, 34, 35, 36, 37, 38, 39. It worked again. Let's try it with our final numbers. 39 to 46. So I'm going to add 7 to 39. I'm going to count up. I'm going to put 39 in my head and count up. 39, 40, 41, 42, 43, 44, 45, 46. It worked. So my rule is that I add 7 to each number. Now, what are the next 3 numbers in this pattern? So if I know that my rule is to add 7, I'm going to start at 46 and add 7. So I'm going to put 46 in my head. 46, 47, 48, 49, 50, 51, 52, 53 is my first one. If I add 7 to 53, that gives me 60. And then I add 7 to 60, and that's going to give me 67. My next 3 numbers in my pattern are 53, 60, and 67. Let's look at this problem. It says, in math class, Fernando learns that the rule add 1 to the side length of a triangle with equal side lengths results in the rule of add 3 to the perimeter. So I have my table here, and I went ahead and filled in the first 2 rows. If I have a side length of 0, the perimeter is going to be 0. If I have a side length of 1 inch, the perimeter is going to be 3 inches. So let's start with side inches, or the side length. That rule is to add 1. So if I add 1, that becomes 2. Add 1, that becomes 3. Add 1, that becomes 4. So now we're going to follow the rule of add 3 to get our perimeter. So we start with 3. We add 3 to get 6. We add 3 to get 9, and then we add 3 to get 12. So I followed my rules, add 1 for the side length, and add 3 to the perimeter. What are the ordered pairs that I can make out of this table? The side length is going to be my x coordinate, and the perimeter is going to be my y coordinate. So 0, 0, 1, 3, 2, 6, 3, 9, and 4, 12 are my coordinates. Now, if I use those coordinates, I can graph them on a coordinate plane. So remember our 3 steps. We go through the door, which is our origin. We walk across the floor, which is our x-axis. And then we get on the elevator, which takes us up our y-axis. So I'm going to go ahead and plot 0, 0, which is right at the origin. 1, 3, 2, 6, 3, 9, and 4, 12. And you can see that my line, if I were to connect those points, continues increasing. Let's look at this one together. Dana and Kent are writing number patterns. Dana's pattern starts with 2 and uses the rule add 3. Kent's pattern starts with 6 and uses the rule add 9. I'm going to make my table. I have a table and I have a column for Dana and a column for Kent. I went ahead and started with Dana's number because it says she starts with 2, and I'm going to add 3. So 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11, and 11 plus 3 is 14. Now on the right-hand side, I have Kent's column. It says he starts with 6 and uses the rule add 9. So he starts with 6. I add 9 to get 15. I add 9 again. That gives me 24. I add 9 again, 33. And if I add 9 one more time, that gives me 42. So now I need to write the first 5 ordered pairs. And I'm going to use Dana's pattern to represent the x coordinate and Kent's pattern to represent the y coordinate. So I have my table here. So my first ordered pair is going to be 2, 6. Dana's number is 2. Kent's number is 6. So my ordered pair is 2, 6. Next is 5, 15. Next is 8, 24. Next is 11, 33. And finally, 14, 42. Now, do you notice a relationship between Dana and Kent's numbers? And if so, what is the rule? How do I get from Dana to Kent's number? Right. Dana's number, or Kent's number rather, is 3 times as many as Dana's number. So 6 is 3 times as many as 2. 15 is 3 times as many as 5. 24 is 3 times as many as 8. 33 is 3 times as many as 11. And 42 is 3 times as many as 14. So I can multiply Dana's number times 3 to get Kent's number.